Do you know what Earth looked like in its chaotic beginnings? Back then, even dinosaurs hadn't appeared yet. The world was ruled by ancient and sometimes terrifying creatures. Earth was like a living hell, regularly undergoing mass extinction events. Today, let's take you on a tour of the dark era before the age of dinosaurs. Around 4.6 billion years ago, Earth was merely a space rock about 10 kilometers in diameter. It faced tens of thousands of cosmic collisions every day. But like a snowball, it grew larger by absorbing dust and meteorites from these impacts, slowly forming into the primitive Earth. However, the surface was still like hell on Earth, covered in scorching volcanic magma and constantly bombarded by asteroids. This brutal state lasted for billions of years. This era is often referred to as the Hadean Eon, named to reflect the hellish conditions before life began. Around 3.7 billion years ago, Earth entered a period of continuous rainfall that lasted millions of years. These rains formed the first oceans and cooled the planet significantly. But that didn't mean Earth became habitable. The atmosphere contained almost no oxygen, and the surface was still plagued by violent volcanic eruptions. It was a barren and deadly world. Yet, deep in those primordial oceans, something miraculous was happening. Though scientists still don't fully understand how life began, the first single-celled organisms did emerge, the ancestors of all life on Earth. Over billions of years, life evolved and became increasingly complex. Then, around 540 million years ago, Earth witnessed the Cambrian explosion, a short period of just over 20 million years when 90% of all modern animal phyla appeared. From simple sponges to complex arthropods, life exploded in diversity. Due to the high oxygen levels in the ocean, many species grew very large, including the 2-meter-long Anomalocaris, which became Earth's first apex predator. But prosperity never lasts. Around 485 million years ago, Earth faced its first mass extinction, wiping out 85% of all species. Scientists still debate the cause, possibly a sudden drop in oxygen or intense volcanic activity. Regardless, this catastrophe marked the end of the Cambrian and the beginning of the Ordovician period. During the Ordovician, oxygen levels rose again, supporting new life. Primitive fish continued to evolve, looking more like the fish we recognize today. Meanwhile, terrifying new creatures emerged like the Orthoceras, a 6-meter-long deep-sea predator, and Placoderms, 3.6-meter-long armored fish that ruled the seas. Plants began colonizing land, first growing near water, then spreading across continents. Most importantly, they absorbed CO and released oxygen, a complex process that laid the groundwork for land-based life. Around 443 million years ago, a collision between a neutron star and a black hole sent gamma radiation to Earth, instantly killing 40% of marine life. This radiation also blanketed the atmosphere, blocking sunlight and plunging Earth into an ice age. Many prehistoric species couldn't adapt and went extinct. Earth's biosphere recovered slowly. By 380 million years ago, during the Devonian period, plants entered a golden age of photosynthesis, enriching the atmosphere with oxygen. The oceans became fiercely competitive, forcing small arthropods to escape to land, giving rise to early land creatures like centipedes and millipedes, the planet's first terrestrial animals. But peace was short-lived. A smaller extinction event occurred, likely caused by climate change and persistent volcanic eruptions, turning much of the ocean into a dead zone. This event wasn't as devastating as previous ones, allowing life to continue evolving. Next came the Devonian, 360 million years ago, a time when fish ruled the seas and plants conquered the land. The dominant predator was Dunkleosteus, a monstrous fish that could grow up to 8 meters long and bite with a force over 6 tons, 3 times that of a modern great white shark. Fish weren't the only giants. The first massive plants also appeared, forming 30-meter-high forests. This created rich ecosystems and made the land even more attractive to sea creatures. But as the Devonian drew to a close, Siberian supervolcanoes began erupting, spewing toxic gases and ash. This led to acid rain and ocean acidification, wiping out 80% of marine species and ushering in the Carboniferous period, around 350 million years ago. This was the age of insects. Atmospheric oxygen reached historic highs, allowing insects to grow to enormous sizes like dragonflies, the size of helicopters, and millipedes, longer than buses. These creatures dominated the food chain, preying on small amphibians and even each other. By the end of the Carboniferous, Earth's continents began drifting and eventually formed a supercontinent Pangaea. This caused many inland areas to dry out, leading to the mass extinction of moisture-dependent plants. The drop in plant life caused oxygen levels to fall, triggering a climate chain reaction. Earth once again became a dry, barren place. Then came the Permian period, 290 million years ago, the final chapter of the Paleozoic era. Earth remained harsh. Glaciers covered the southern regions of Pangaea, making life nearly impossible there. The inland areas became arid deserts, where only drought-resistant species could thrive. But the end of the Permian brought catastrophe. For nearly 100 years, Siberian volcanoes erupted relentlessly, spewing lava and releasing massive amounts of CO. This trapped heat in the atmosphere, raising global temperatures sharply. The heat sparked wildfires, destroying animal habitats and starving herbivores. Meanwhile, the oceans absorbed CO, becoming increasingly acidic. Around 250 million years ago, this chain of disasters peaked, wiping out 96% of marine species and 70% of land vertebrates. Earth's ecosystems collapsed, setting life back by 300 million years.